Hello to everyone! I'm happy to give you an overview about basic study designs. I will focus on experimental study designs. That means those studies which assess if there is a cause-effect relationship. Here, the investigator introduces an intervention called independent variable to observe its effects on the outcome, called dependent variable. Experimental studies can be divided in two main categories: randomized studies and quasi-experimental studies. As the word randomized says, here lies the main difference. In randomized studies, the participants are randomly assigned to the groups. That means that they are assigned by chance, and each participant has the equal chance to end up in the intervention group or in the control group. Instead, in quasi-experimental studies, the group allocation is not performed randomly. Randomized studies can be divided in two groups according to their design. They can have either a parallel group design or a non-parallel group design. Parallel group designs can have either one independent variable or two or more independent variables. Parallel study designs with one independent variable can have three different situations: intervention versus placebo, intervention versus active treatment, or a multi-group design. Let's start with the parallel design, where the experimental intervention is compared with the placebo. Patients are divided in two groups, one taking the experimental intervention and the other one receiving placebo. The situation is very similar for the parallel design, where we compare the experimental intervention versus the active treatment. Patients stick to the assigned intervention. So the only difference is that instead of placebo, the control group receives the active treatment. The last parallel design with one independent variable is the multi-group design, where we can have more than two groups. We have one independent variable, of course, which is the experimental intervention assigned to one group, and then two control groups. As I explained before, parallel study design can also have two or more independent variables. That means two or more experimental interventions. This is the case of the factorial design. You will find the factorial design described as the 2x2 or 3x3 factorial design. This picture in particular depicts the 2x2 factorial design. Each group receives two treatments at the same time. The first group receives the two experimental interventions, A and B. Then, the second group receives intervention A and the placebo of intervention B. Similarly, the third group receives the intervention B and the placebo of the intervention A. The last group only receives the placebos, so placebo A and placebo B. The rule is always the same. Since the design is parallel, the patients must walk on the same line. They cannot switch groups and interventions. The last experimental randomized design that I would like to discuss with you is the crossover design, which is part of the non-parallel group designs. The name says it. In the crossover designs, in fact, we have two groups, one receiving the experimental intervention and the other one receiving the placebo. The difference here is that at a certain point, patients switch from one group to the other, so from one intervention to the other. Let's better look at it. Patients from Group A receive the experimental intervention during the first phase. And then, after the so-called washout period, where participants do not receive an intervention, the patients in Group A take the placebo. For the patients in Group B, the situation is similar but opposite. So, when should we prefer one design to the other? For sure, it's important to know the strengths and weaknesses of each design. For instance, parallel designs are very simple to analyze, apart of the factorial design. Moreover, compared to the crossover design, parallel designs are more clean because patients do not change their treatment. And so, parallel designs allow to have a between-group comparison. However, also depending on how many groups, they require large samples. On the other hand, the crossover design uses the same patients twice. First, they receive one treatment and then the other one. So this means that my sample can be smaller. It is sometimes more feasible to perform a study with a crossover design. For instance, it can be a good choice when we have a rare disease. Also, since the participants are the control of themselves, the crossover design doesn't only allow the between-group comparison, but also the within-group comparison. That is, how patients in Group A respond during the first phase compared to their reaction during the second phase. However, of course, also crossover designs have their drawbacks. Do you remember the period between the two phases, the washout period? This period is fundamental to avoid the carryover effect. That means to prevent the participants to have residual effects of the first intervention. How do we know how long the washout period should last? The World Health Organization states the interval washout period between doses of each formulation should be long enough to permit the elimination of essentially all of the previous dose from the body. The washout period should be the same for all subjects and should normally be more than 5 times the median terminal half-life of the active pharmaceutical ingredients. The minimum washout period should be at least 7 days, unless a shorter period is justified by a short half-life. There are more things to consider and discuss, indeed, but I hope that you enjoyed this video.